Okay, thanks for coming, guys. And like to let you know a little bit about a new type of company. We are not an IP provider, and we're not an IP reseller or an IP rep firm. But what we do is help the SoC chip design companies increase their confidence in the third-party IP due diligence procedure. So what I'm going to be talking about today is when your team is going to outsource the third-party IP, you can actually also outsource a part of that whole sourcing methodology to the folks at SiliconIP. Now there's a typical chain that goes, a sequence of events that goes from chip architecture planning to product definition stage to eventually looking for available IP through the chip estimate portal. And then eventually, once the IP has been chosen, then to have that IP become part of an internal IP management system, such as you might see from IC Manage. So what our job for the SoC company is to find the IPs that best fit the SoC application requirement and also best fit relevant to the next step of managing IP. So you want these IP that are going to be most compatible with your system in terms of SPICE models, design rules, and testing. We focus primarily on the silicon-based IP, sometimes referred to as GDS IP or hard IP. The RTL components we get involved with are when there are controllers involved, but primarily focused on what we call the GDS-based IP. So based upon the deliverables that we've provided to our customers in the past and at previous conferences where we've discussed these trade-offs, one thing to take away is by implementing a methodology, whether it's the one I'm showing here or whether it's the one that you have, but you continually enhance it, you're going to be able to save a couple $1 million on every tape out and a couple of months time to market. So that's the key thing. It's having a methodology and using what you learn at each tape out, improving your methodology, which is really what helps bring different portions of your design team together to make a coherent decision-making process. So our job is to work as an adjunct to the SoC, the existing IP sourcing and management team of the SoC company. We come in, we've been doing this kind of work for the past 13 years, so we're very quick up to speed, and can come in when there's the actual sourcing methodology and then can leave and not be an ongoing expense after the chip tape out has completed and ramp is finished. So one of the things that you'll notice is that there are many different areas in terms of due diligence. We have both in the product itself, where we look at the technical performance of the IP and the quality performance of the IP. There's also embedded within all of this an actual sourcing, a risk assessment of the different sources. And all of these have to be balanced and ranked and then matched with what are the most important care abouts from the chip designers, SoC chip designers spec interface requirements. Our value comes in the fact that we interact with many different tape outs and many different IP companies across many different applications. The typical SoC design team gets really one point of view, and that's relevant to their specific project and the specific implementation of how IP is used. Our, again, since being in this business for about 13 years, what our value is triangulating the results of many of these tape outs in many different applications, understanding how the IP works, and understanding what are the real world issues to integrate IP and get it to function as per the SoC spec plan. And the best practices that I'll show here are a methodology that's data driven. It comes in the form of worksheets that I'm going to give a couple of case studies to let you see something in practice. And again, the point is to consider What are the most important trade-offs that your design team is willing to live with relevant to the type of IP in terms of spec and performance, as well as what sort of support you need from your IP provider, what sort of track record does your IP provider have in actual systems in these specific applications. The second area that our methodology really helps with is a documented approach. So one that is capturing results at each step of the due diligence process. You're quantifying results. So it's not subjective. It's not just one team being in charge of the evaluation procedure and other teams such as the engineering guys that actually have to take the incoming IP and integrate it is left out. This methodology actually promotes this internal cross-team communication and even buy-in of ranking the IPs to find which is best suited for the application. Our team members come from primarily the foundry background. Myself and another colleague at TSMC built what's called the TSMC 9000 program, which is the multi-stage approach to validating pre-tape out IP, silicon IP, split lot IP to make sure that the IP actually performs to the datasheet specs across process temperature and voltage conditions. So our function is to validate all the claims that the IP providers make in terms of actual data that is captured and will support specifically the datasheet items. So we're not doing a retest, but we're looking to, our methodology shows how much confidence you can put into the claims that the IP vendor provides. One example of this in the audience is Johnson Tan from Granite River Laboratories. And what they do is they're an industry standard certification test house. And what they do is make sure that if it's PCI, USB, etc., that the IP actually functions across the entire spec range, which is process variation, temperature, and voltage. If you think about what happens at a plug fest, it's set up in a hotel. There's a conference center. There's a table set up, and you're plugging devices into systems, but it's in this kind of controlled environment. That's not the real world. And so what, fortunately for Johnson, is what the chip guys find out is a lot of times the IP may pass a plug fest, but it doesn't actually pass the full datasheet conditions across process voltage and temperature. One of the other, I mentioned about the TSMC 9000 methodology, so it's looking at silicon validation. We also have a few members that are in the, come from the chip design background, which are actually in taking this incoming IP, doing the internal sourcing. So we have both the silicon foundry perspective as well as a SoC design team perspective. And that's our core group, that's our methodology group. Then when we get into application or functional specific areas, we bring in other members that we've worked with throughout our careers, for example, in SerDes and these very high speed, timing critical applications, where you really need to understand not only just the IP block itself, but in the condition in which it's tested in. What is the board level? Is it a very expensive, a very well-contained board? Are the traces match nicely? If you do silicon validation in that kind of environment and you expect to put that same IP block into a very low-cost board that maybe gets manufactured in Southeast Asia, where the costs are really kept to a minimum, that IP is most likely not going to work based upon what the test report shows, given a nice clean board and test environment. Okay, so this is first of two applications that we'll walk through as a case study. The first one is in Wi-Fi, and the second one is in UFS, the Universal Flash Storage for solid-state drives. So in this particular project. This was about, well, towards the end of 2010, very beginning of 2011. It was for the N and AC specifications in Wi-Fi. The client is a large top IDM. They have their own internal design team, but because they have many different business units, and because the different business units have different, they have specific implementations of the IP, their internal IP team was not able to deliver all of the different configurations. So the project is look at a third party to help augment the resource of the internal. But it has to be matching the capability, it has to be matching the architecture trade-offs that the IDM has made and fit into their design flow as seamlessly as possible. Our deliverable is a quantified ranking that is a result after going through these different technology, due diligence, the silicon validation, and also the sourcing risk assessment. And ranking, which I'll show you on these three axes, but it's quantifiable. We provide the full results of the ranking. We provide the raw data because our client may decide to reprioritize the care-abouts in terms of which one is most important, second, etc. But our ranking is based upon that feedback from the client. So the way we approached this was the full chain. This had to be an entire chain. From the firmware, the software, all the way to the power amplifiers. And so what this means is you're going to have the power amplifiers, a different piece of silicon, but you got to make sure that there's proof of interoperability and understanding in terms of how to implement the IP in the different application cases. So big picture, these are the three blocks. The way we approached this was one of the criteria from the client is to have minimal interaction from the client side. So we're looking at what we called one-stop or shop or full chain service providers that could provide all the elements, the firmware, the RTL, the PHYs, etc. And what we looked at there was a combination of design houses where the people the principals at these design houses have specific background and expertise for many years in this IP in these kind of applications. Secondly, we looked at back a couple years ago, there were just a few SoC chip guys who in certain strategic carve-outs would actually license their chain to other non-competing entities. And then we looked at the typical so-called best-of-breed approach of the individual IP providers. So you can imagine there's trade-offs. For the bottom row here, someone is going to have to really coordinate the interface between the different providers. So that was the approach we took. Hypothetical numbers, but giving you the idea that there's going to be trade-offs in terms of how well, what the performance level of the IP works. Sometimes, of course, if it's just minimum spec levels that are necessary, you don't get any value for any performance above that. But when you get into things like antenna, beamforming areas, there's a lot of a quality of service differences that slightly better performance on the IP portions will make a dramatic impact in terms of the SoC. So this is to give you an idea of a very simplified result, and again, all the data underneath to come up with these results is what we deliver. Right. And then you really need context. So between all these different implementations, whether it's a design service company, whether it's an SoC provider, or the individual IP guys, you need to have some context in terms of are the guys you're going to get the IP from, are they competing? Are they providing the same kind of IP to some of your competitors? So you can understand there may not be a lot of differentiation there. You also want to know what kind of background do the IP providers have in terms of actual silicon working in these applications. So the point is that this is, from our experience, we see that IP sourcing is something that the management of, whether it's a SoC company, whether it's the management of foundries that have an IP program, there's a lot of questions and concerns about how does all this mysterious evaluation and decision making go. So the point is having something that's documented, something that's data driven, that's shared. And this, our method, what I'm showing you here is a baseline. It's something that works in 80%, and then what we do with our clients is customize for the specific type of SOC requirement and specific kind of apps and the IP that you're looking at. So the key is to, whether it's your own methodology or it's to use this or a version of this, it's communicating between the different engineering teams, whether it's the validation guys, whether it's the system architect in terms of is the IP spec performance really satisfactory to the chip requirements. Second project, mobile devices today, solid state drives really kicked the solid state drive effort off, becoming much more prevalent in other type of mobile devices. So this particular approach was the typical evaluation, but also based upon the initial work that the chip company went through. The IP needs to be ported. So the process that the chip company is targeting, none of the IP providers had it currently on the roadmap. So based upon our experience, again, working at the foundries and helping manage porting of IPs to new processes, we were going to be a subcontractor kind of managing the IP porting process. So our deliverable in terms of due diligence was had a heavier weight on the sourcing risk. The reason being that the typical IP provider that this company used wasn't going to be able to make the milestones, the timing milestones. So they were kind of looking at IP providers that they don't have a lot of history on. So we were doing a lot in terms of this sourcing risk, looking at methodologies, design audits that we would go through to make sure that there's enough marginality built into timing circuits or sense circuits, again, so that when the chip actually works in the process corners, you're not going to have failures. The other area that we look into is it's one thing to evaluate IP in a standalone test chip, for example, a PLL and a DAC. Separate test chips, separate pristine environments. When you put these two together in systems, you're going to have interference and there's going to be effects. So you want to understand how well the IP providers in both these areas know about these sorts of effects, what they've done to manage those sorts of effects. So this, the first set of slides are in what we call the product due diligence. So you're looking at what is the spec, what are the care-abouts for the SoC team, and we're matching this up to the JEDEC minimum specification for the universal flash. Now, as all you chip guys know, when you introduce products based upon industry standards, you have options. You have options on how to implement these standards. So it's not just one size fits all. And so that's what we're looking to do, is to make sure that
you could also do, we could figure it out.
for example, how the jitter in the eye window is going to perform in the particular implementation, again, across PVT points. You're going to have things like the different, what they call gears, and UFS uses, some gears are mandatory, some are not used at all, and other gears are optional. So again, this is where you want to have expectations between the design team and the IP sourcing team be met with what's actually delivered by the IP provider. There's a lot of things in terms of ways to terminate the lanes on the MIPI M5. You also have to understand that there's going to be the electromigration effects, and from a system level perspective, that's important. So there's different methodologies that are in this area that the SoC provider can use as levers with the IP to minimize, to localize these EMI effects. So that's again a expectation alignment that you want to, that this sort of methodology allows you to get between your engineers that are going to be implementing the IP and the ranking in your actual sourcing decisions. In terms of the risk of a source, there's lots of areas that you want to look through. If typically this sort of risk assessment is done on the maybe levels, IP companies levels 7 and below, if you will, in terms of top ranking. So what you're really looking at is what is the background, what's the history of the principals of the company, the guys who founded the company. You know, many times they've come from chip companies at IDMs and then gone into this IP business. And we're talking about the more analog mixed signal type of IP guys in this specification. But what we want to know is, you know, how are they funded? What is their revenue base like? And what you're really concerned about is, are they going to be there through your ramp into production time? You know, you don't, yeah, it'd be nice if they're going to be there for 10 years from now, but what you really need to be concerned about is that you're going to get your chip up and running, that if something happens to these guys, that you have escrow provisions to be able to have access to the design and complete your tape out. You know, you want to understand the number of licensees they have over the past couple of years, how many different design teams they have, how many times they've actually implemented macros and different process technologies. Because in analog mixed signal, it's very much a learning curve event. And the other things you want to look at, I mentioned about test chips. Are you testing in a noisy environment, or are you testing in a nice clean environment? Because your chip, as good as it gets laid out and planned, there's obviously lots of noise, and that's the real world the IP is going to live in. Going to do audits of the test lab is hugely important. What is the state of the test lab? Is it really messy? Is it very nice and neatly organized? Or is there documented methodologies that are used for testing? How are all the data provided to you? Or does the vendor conveniently to use some data as escape data, throw it out, and only provide a subset? The packaging EDA script levels, are they compliant with your EDA internal flow? And so that wraps it up where, again, the point is that there's a methodology that's used. Our methodology is a very good baseline for the clients so far. Your baseline, hopefully you're reinventing, you're taking what works well, you're learning the mistakes that happened in the past tape outs and plugging those holes and making adjustments. So the key is that now this methodology is also available to even the smallest type of SoC company, not just the big guys who can afford to have an internally dedicated IP management team. So thanks for coming. Do you guys have questions?
Go ahead. Speak really close.
Out of all the companies they have seen, do you see any standard emerging out of all these IP companies?
Could you repeat what about standard?
Do you see any standard, maybe directory structure or some sort of standard emerging out of these different IP companies?
Directory structure?
That's just an example.
Yeah.
So IPs from company 1 can work well with IPs from company 2 without a lot of massaging.
Yeah, exactly. So that's exactly where we're at. So as we go forward, there will be essentially web-based access to those cases. Which IPs work well together, which kind of environments. Well, we're not there at that stage yet. Now, when you talk about things like PLLs, that they'll probably never become that way because everyone wants to do that so uniquely. But when you get into things like foundation IPs, standard interface IPs, yes, there are definitely cases that work much better.
We're good.